is a pleasure to have this opportunity to talk to you. Some of you may have seen our show models, and I hope you like them. It is the purpose of this presentation to report to you on the engineering background of our 1953 lines, with perhaps a brief glance ahead. Last fall, I went to England and Scotland to talk about automatic transmissions at meetings of one of the British technical societies. In England and in Europe generally, the problem of providing individualized transportation is met by scaling the product to fit the individual's pocketbook. In this country, we've handled the problem of self-propulsion quite differently. Here, the only new transportation we sell is cars. Furthermore, we only sell these new cars to a part of the population. Then, in effect, the new car buyer provides for the transportation needs of the rest of the people through the sale and resale of used cars. The European system produces poor individualized transportation, and the cost to the individual is high. On the other hand, our system produces excellent individualized transportation, and the cost to the individual is low. The reason our system works is because we have a fairly fast turnover of new cars. They aren't handed down as heirlooms, and that's where the engineers and designers come in. It's our job to make sure that enough people perform the economic function of making used cars out of new cars to keep the rest of the people supplied with transportation. We do this by means of the improvements we build into our new models each year. Of course, the automobile industry is not averse to selling cars and earning a profit. But from the point of view of the economy as a whole, that is not so important as the fact that ours is the best method we know for providing everyone with a car to fit his purse and purpose, to paraphrase a slogan you may remember. Now, before I start talking about some of the new things in GM's 1953 line of cars, I'd like to review briefly some significant improvements in our engineering and research facilities that have been made during the last 3 years. One important addition is, of course, the new General Motors Technical Center. It is being built on a site of more than 800 acres just north of Detroit. Eventually, the Technical Center will be the home of more than 2,500 engineers, designers, technicians, and other employees of the research laboratories and of the styling, process development, and engineering staffs. The engineering staff group of buildings has been in operation for 2 years, while the research building group is nearing completion. In the GM divisions, there also has been expansion of engineering facilities. Important additions have also been made to our road test facilities. The regular, or as we now call it, the commercial proving ground at Milford, covers more than 1,500 acres. On an adjacent tract of 1,000 acres, GM has developed a separate military proving ground, a complete laboratory and road system for testing tanks, trucks, and other military vehicles. We are just completing a desert proving ground on a 2,200-acre tract near Phoenix, Arizona. It already includes a 1.5 mile straightaway and a 5-mile circular track banked for speeds up to 120 miles per hour. The advantage at Phoenix is that it provides both high speed and a high temperature test condition throughout most of the year. Here are some shots of our road testing at Phoenix. Obviously, we can't test every car General Motors makes, but we do give a thorough test to every new development and every new model before they are put into production. We also make use of the desert and mountain terrain near Phoenix to determine what such things as rough roads, heat, and dust will do to a car. These test operations are at Milford, Michigan, not Arizona. In addition to tests on new designs, we also run a 25,000-mile durability test on each of our new car models over roads like this to give us a quick check on the behavior of production-built jobs, and also on the production-built jobs of our competitors. Then we take each car apart and put the pieces on tables so they can be inspected by our engineers to see how they stood up under 25,000 miles of hard day and night continuous driving. Of course, we make many other tests at the proving ground, some of which are quite spectacular, such as this. We are always seeking better ways of making tests and inspections of production as well as experimental parts. This is the surface gauge, an ingenious device developed by our research laboratories, which makes possible quick, precise measurements of surface roughness in the laboratory, in the shop, or even in the field. This instrument has a single diamond stylus which is drawn across the surface to be measured. Irregularities as fine as 1/1,000,000th of an inch are registered on the dial. In order to provide a standard for calibration, a set of 5 precision roughness specimens is furnished with each gauge. Using this device, an operator can take accurate readings of surface roughness after only 1 or 2 trials. Now let's talk about some engineering that has high public visibility. One of GM's most important contributions to comfort has been the control of car temperature. Today, our efficient car heaters make it possible, even in the coldest weather, to have an adequate supply of fresh heated air. Windows no longer frost up, so winter driving is much safer. Now we are offering car cooling for hot weather comfort, also with a safety factor because fresh, cool air in a car keeps windows from fogging up during a rainstorm. It takes a good bit of equipment to cool a car. Part of it has to be in the trunk, but it is so ingeniously tucked away that ample luggage space is still available. If you ever have experienced the temperature and dust conditions of some parts of the country, you will agree that in those localities, hot weather air conditioning is almost a must. It also provides great relief for many who suffer from some form of hay fever. Now a word about performance. Horsepower has been increased a little on GM's 1953 cars, and because the overall accomplishment is an important forward step, I want to say a few words about it. Our passenger cars of 25 or more years ago were like some of the present-day European passenger cars, in that they used engines of rather small displacement running at high speed. Since cars in those days did not have automatic transmissions, high engine speeds combined with the rear axles having high ratios were necessary to achieve satisfactory acceleration and hill performance without excessive shifting. As a matter of fact, then and for many years thereafter, cars delivered to hilly regions were equipped with so-called mountain axles having ratios as high as 5:1. This meant that standard cars with lower axle ratios, in other words with less engine speed reduction, were penalized on performance in hilly areas, while those with the higher mountain ratios were penalized when driven in level areas. The higher mountain ratios resulted in very high engine speeds with accompanying noise and wear, and also loss of efficiency and loss of gasoline economy due to high engine friction. With the development of automatic transmissions and high compression engines with increased horsepower, it has become possible to use low final drive ratios, in many cases as low as 3:1. This results in low engine speed, which means less engine noise, less wear, and reduced engine friction with the resulting increased efficiency and gasoline economy. Our 1953 cars are more ideally suited for travel everywhere, and this is an important step forward. Their improved performance and better acceleration are not only more pleasing to the customer, but also permit safer passing in traffic and make it possible to move more traffic on any given highway. Here is a chart showing how the compression ratios of our engines have risen over the last 25 years. And this chart shows the change in horsepower ratings. You will note that over this 25-year period, there has been a fairly steady and pronounced increase in both compression ratio and horsepower. This next chart traces the improvement in acceleration over the last 25 years. And this one shows the improvement in fuel economy. In other words, except for the war years, the increases in compression ratio and engine horsepower have resulted in both better fuel economy and improved acceleration. Ralph Thomas, president of the American Automobile Association, recently made the point, and I quote, "Additional horsepower is all to the good provided we exercise horse sense in using it." He added, accident records prove that we have. Mr. Thomas also said, "One most important function of power reserve is its use in zooming out of an emergency and to cut down the time needed to pass another vehicle." We are again making improvements in our passenger car automatic transmissions. Chevrolet's new 2-range Power Glide with automatic shift gives definite advances in both performance and economy. The new Buick twin-turbine Dynaflow also provides outstanding performance with economy of operation. Pontiac, Oldsmobile, and Cadillac have hydromatic transmissions with additional new refinements in automatic shifting. Why do we have three basic types? Because General Motors encourages independent thinking, and we happen to have three schools of thought on passenger car transmissions. And we haven't closed the book yet. Out of the Technical Center, the development group responsible for our first automatic transmissions has been working on advanced designs ever since. As you perhaps know, GM's Allison division is also engaged in the development and manufacture of automatic transmissions for heavy vehicle applications. In short, GM leadership in the automatic transmission field is not just happenstance, and it's a position we mean to keep. Sometimes we have to develop entirely new engineering tools or testing methods to achieve desired objectives. This is a plastic housing enclosing an experimental type twin-turbine torque converter. The housing is filled not only with a colorless oil, but with thousands of tiny plastic balls. In the laboratory, pictures of experimental drives such as this are taken with a special movie camera that shoots 7,000 frames per second, giving us a permanent record of action which cannot otherwise be observed accurately. We are thus able to study flow patterns and determine the advantages and disadvantages of various blade designs. Now let's consider another kind of performance. To the woman of the family, performance means more often than not ease of operation. Here's GM's latest power application, power braking. Our youthful demonstrator can bring her car to a stop with almost no pedal effort. In fact, without even lifting her foot from the floor. Ever since Mr. Kettering's self-starter put women behind the wheel, steady progress has been made in taking the effort out of car operation. Power steering makes it possible for the smallest woman to handle the largest car with ease. It has, in truth, taken the work out of parking. Nor is putting up the top any longer an operation that requires brute strength and produces pinched fingers. A flick of the finger and the power window lifts go into action, or the seat adjusts itself to the desired distance from the wheel. This is our newest device, the slide-away front seat. While this seat, which is standard equipment on the new Buick and Cadillac two-door models, is not an example of power application, it does contribute definitely to ease of car use. Some of you may wonder what keeps the slide-away seat from sliding when the car stops suddenly. Here is the answer, our new inertia lock. A sudden stop causes this weighted lever to fly up and lock the sliding device. One of the newer GM engineering developments serves to give the expression riding on air a basis in fact. The air suspension ride is developed by GMC Truck and Coach Division. Air suspension ride applies the principle of the pneumatic tire to coach body suspension. The suspension consists of 4 units, each composed of an air chamber and 2 bellows. This revolutionary new suspension means safer, softer, and quieter riding for bus passengers. Because there is no friction to overcome, it responds instantly to the slightest axle movements, even those caused by the tread of the tires. The leveling valve automatically meters compressed air into the system so that as the coach is loaded, the air pressure is increased to maintain a constant body height. Other advantages are no squeaks, no lubrication, no maintenance, and long life. Unfortunately, and here is the anticlimax, as now designed, this suspension is suitable only for large vehicles like buses. This concludes our review of current engineering work in General Motors. I hope it demonstrated convincingly that we do not let past experience or textbook theories prevent us from investigating any possibilities for making better products for our customers. On the other hand, many of our projects still are in the experimental or theoretical stage, and you may be certain these will remain only possibilities until they've been proved satisfactory under all of the varied conditions they will encounter in actual service. I think all of you realize making automobiles calls for stylists as well as engineers. The styling of GM products speaks eloquently for itself, but I'm sure you will be interested in the GM people and facilities behind that styling. And so, for the second part of this program, it is a real pleasure for me to turn the meeting over to Mr. Harley Earl, Vice President of General Motors in charge of the styling staff.
Sound engineering is indeed of prime importance in every good product. Mr. Chayne's review of General Motors engineering for 1953 was convincing proof to me that General Motors will continue to enjoy the leadership through engineering. Another prime ingredient of sales leadership is design leadership, styling that builds eye appeal into the product. The very favorable public acceptance of General Motors styling is made possible by the unique combination of policy, facilities, and personnel. What a stylist does, how he does it, and how he thinks is difficult to describe with words. And so we attempted to portray the stylist in motion picture called The Look of Things. I believe this film, far better than any words of mine, will give you a better understanding of the important roles played by stylists and styling in General Motors.